Today we're going to cover right triangle trigonometry, coterminal angles, the unit circle, exact values of functions, and trig equations and identities. So first we'll go over the two special right triangles. First, the 30, 60, 90 triangle. I'm just going to draw it really quick. As you can see, the sides would be x radical 3, x and 2x. We have the 45, 45, 90 degree triangle. Two sides are equal. The sides are x, x, and x radical 2, and the hypotenuse is always across from the 90 degree angle. Now let's go over sine, cosine, and tan, or SOHCAHTOA. Sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. And tan is equal to opposite over adjacent. We're also going to go over converting from radians to degrees. So you would just multiply it by 180 over pi. And when you go from degrees to radians, all you have to do is multiply by pi over 180. Now let's go over how you will find values of sine, cosine, and tan. You can use the knowledge from the special right triangles and your knowledge of sine, cosine, and tan. Here are the angles of the unit circle in radian and degree form. You can just watch me, but I'm just using the rules we went over just now. And you can use this to find any angle like in any quadrant. Just use all students take calculus. This represents what values are positive, and any other angle will be negative, except in quadrant 1 where all values are positive. Now let's go over coterminal angles. Coterminal angles are just angles which touch an initial side and terminal side, which would look like this. So I'm just going to draw the y and x-axis. The red line represents the initial side. And now we'll draw the terminal side and theta in between. And I'll draw in green what a coterminal angle could look like. So that would just be 360 minus theta. But there's an infinite number of coterminal angles, and they could be positive or negative. So it would be theta plus or minus 360n, or theta plus or minus 2 pi n. And that's in degrees and radians form. Now let's go over the unit circle. So, as we all know, the radius is equal to 1, and the center is at the origin, 0, 0. And the equation would just be x squared plus y squared is equal to 1. This derives from our original equation of the circle, but we substitute 0. We know when we substitute 0 for h and x, and 1 for the radius, this would just be x squared plus y squared is equal to 1. We know cosine theta is equal to x and sine theta is equal to y. So x comma y becomes cosine theta comma sine theta. And we know the angles covered in the unit circle are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And according to all students take calculus, we can figure out whatever coordinates would be in terms of being positive or negative. So let's quickly draw the unit circle. We should have a good understanding of this, but remember the reference angles can determine any coordinate of that reference angle. So any angle with the denominator of 6 in radical form would have coordinate radical 3 over 2, comma 1 over 2. Any angle with the denominator 4 in radical form would be radical 2 over 2, comma radical 2 over 2. And any reference angle with the denominator of 3 in terms of pi will be 1 over 2, comma radical 3 over 2. And we'll remember all students take calculus to determine in which quadrants cosine and sine would be negative or positive. Trig identities and equations. Cosine theta is equal to x, so the reciprocal secant theta is 1 over x. Sine theta is equal to y, so the reciprocal cosine theta is equal to 1 over y. And tan theta is equal to y over x, so the reciprocal cosine theta is equal to x over y. Now let's go over to the formulas. Sine squared theta plus cosine squared theta is equal to 1. We can get two new equations. Sine squared theta is equal to 1 minus cosine squared theta, and cosine squared theta is equal to 1 minus sine squared theta. We know secant squared theta minus tan squared theta is equal to 1 because sine squared theta plus cosine squared theta is equal to 1 divided by cosine squared theta. We know secant squared theta is equal to 1 plus tan squared theta, and secant squared theta minus 1 is equal to tan squared theta. I'm just going to move this to the side so I could go over the next formula. We know cosecant squared theta minus cotan squared theta is equal to 1 because sine squared theta plus cosine squared theta is equal to 1 divided by sine squared theta is equal to this. Cosecant squared theta is equal to 1 plus cotan squared theta. Cosecant squared theta minus 1 is cotan squared theta. And I'll just underline the main formulas, but we can get any of these formulas from sine squared theta plus cosine squared theta is equal to 1. Let's practice. What would cosine of 30 degrees be? We know the reference angle is pi over 6, but we can draw our triangle and figure this out. The sides would be 1 radical 3 and 2, because x would be equal to 1. Cosine is adjacent over hypotenuse, or radical 3 over 2. What if we had cosine of 45 degrees? We can draw our triangle to figure this out. The sides are 1, 1, and radical 2. The reference angle is pi over 4. Cosine is adjacent over hypotenuse, or 1 over radical 2. And that's radical 2 over 2. What if we had secant of 30 degrees? We know secant is the reciprocal of cosine theta. And we know cosine theta was radical 3 over 2. So therefore it would be 2 over radical 3, or 2 radical 3 over 3. What if cosine theta was equal to negative radical 3 over 2? So we know the reference angle is pi over 6, and that's 30 degrees. Any other angle is pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. According to all students take calculus, quadrants 1 and 4 have positive cosine values, so they are not included. It can only be quadrants 2 or 3, which would be 5 pi over 6 or 7 pi over 6. What if we were asked to find the measure of a negative angle that was coterminal with 30 degrees? So 30 degrees plus or minus 360n. If we minus 360 degrees, that would be negative 330 degrees. But we can go infinity. What if we had minus 720? That would just be. What if you were asked to find the measure of a positive angle coterminal with pi over 6? So pi over 6 plus or minus 2 pi n. If we just added 2 pi, that would be pi over 6 plus 12 pi over 6, and that's 13 pi over 6. If you added 4 pi, that would be pi over 6 plus 24 pi over 6, and that's 25 pi over 6. What if you had sine of pi over 4? We know the coordinate at this reference angle is radical 2 over 2, comma radical 2 over 2. The sine value will be the y value, which is radical 2 over 2. What if you had tan of pi over 4? Tan of theta is sine theta over cosine theta. So the sine is radical 2 over 2, and the cosine is radical 2 over 2. When we divide those, that's just equal to 1. So tan is equal to 1. What if cosine theta was equal to negative radical 3 over 2, and theta is in the third quadrant? We would have to find the exact value of sine of theta. So the reference angle we know is pi over 6. And in quadrant 3, that would be 7 pi over 6. The coordinate radical 3 over 2, comma 1 over 2. Let's look at all students take calculus. In quadrant 3, tan is positive, sine is negative, cosine is negative. Therefore, the value of sine would be negative 1 over 2. What if we were asked to prove the identity? Secant x minus tan x times sine x is equal to 1 over secant x. So secant x is just 1 over cosine x. We can make this sine x over cosine x times sine x. And we can make this the reciprocal of 1 over cosine x. So 1 over cosine x minus sine squared x over cosine x is equal to cosine x. 1 minus sine squared x over cosine x is equal to cosine x. We know from our original formula that cosine squared x is equal to 1 minus sine squared x. So cosine x over cosine x is equal to cosine x. What if we were asked to prove the identity? Secant theta over cosine theta minus tan theta over cotan theta is equal to 1. So secant theta is just the reciprocal of cosine. Tan is sine theta over cosine theta. Cotan theta is cosine theta over sine theta. You know sine theta over cosine theta multiplied by sine theta over cosine theta will just give us sine squared theta over cosine squared theta. And we know the reciprocal of, and we know this would be 1 over cosine squared theta. When we subtract those, we get 1 minus sine squared theta over cosine squared theta. According to our original formula, 1 minus sine squared theta is equal to cosine theta. So this would equal 1. It's correct. What if we had secant theta times sine theta over tan theta plus cotan theta? Is that equal to sine squared theta? So we know secant theta is the reciprocal of cosine theta. We know tan theta is equal to sine theta over cosine theta plus cosine theta over sine theta. So this would be sine theta over cosine theta divided by sine squared theta plus cosine squared theta over cosine sine theta. Sine squared theta plus cosine squared theta is equal to 1. Sine theta over cosine theta times cosine theta times sine theta just becomes sine squared theta over 1. So this is correct. Tan squared theta minus tan squared theta is equal to 2 sine theta, when theta is equal to 45 degrees. Let's see if this is true. So 1 over cosine squared theta minus sine squared theta over cosine squared theta, is that equal to 2 sine theta when theta is 45 degrees? When we combine this, 1 minus sine squared theta over cosine squared theta, and set it equal, and replace 1 minus sine squared theta with cosine squared theta, we get 1 is equal to 2 sine squared theta. Now we can replace theta with 45 degrees. The reference angle is pi over 4. At pi over 4, the coordinate will be radical 2 over 2, comma radical 2 over 2. So sine will be radical 2 over 2. When we square that, we get 2 over 4. When we multiply that by the 2, it's equal to 1. That was our last problem. Please look in the description for any practice.